All right, so today we're going to be looking at some shapes that have been scaled. We talked about scaling yesterday, some scale factor. So it's basically an enlargement or a reduction, and we're going to look at what happens to the area and the perimeter when we scale these up or scale these down. Because if we double or triple the side lengths, that doesn't necessarily mean that the area is also going to double or triple, which is a common misconception. A lot of students would just assume if I double all the sides, then the area doubles, or if I triple all the sides, the perimeter triples. That may be true, it may be not. We're going to discover it here together. So first of all, if we look at the first problem, we've got a scale up. It's going from a small shape to a big shape. It's the same shape, at least it looks like it, just a larger version of it. So it's not a new shape. It's not a different kind of triangle. It's not a quadrilateral or anything like that. So the first question is just asking us, are they similar? So at first glance, they look similar, but we need to prove it mathematically. And so what we're going to do is we're going to set up ratios and set them equal to each other with the corresponding sides and see if they're in proportion. So the 6 is going to match the 12. Those are kind of like the heights of those triangles. And just right off the bat, if you look at that, 6 over 12 is going to give me 1/2. So I'm basically testing, do all of the other corresponding sides, when I set them up in a ratio, equal 1/2 or equal each other. So the 10, kind of on the diagonal, matches the 20. And the 8 matches the 16. This is true. All of these are going to equal 1/2. If I divided these in my calculator, I would get 0.5. If you want to think of it like a unit rate, they're all going to give you the same unit rate. So are the triangles similar? Are the sides proportional? And in this case, the answer is yes. Now, scale factor. There's two scale factors for every problem because it depends which way we're going, which direction we're going. So if we're going from left to right, remember scale factor is always multiplication. So not what did I divide the numbers by? What did I multiply the numbers by? So going from left to right, 6 became 12, 10 became 20, 8 became 16. That's a scale factor of 2. I'm multiplying everything by 2. Going the other direction now, a lot of students would say, well, I'm dividing by 2. So the scale factor is 2 still. But scale factor is always multiplication. What did I multiply 12 by to get 6, 20 by to get 10, 16 by to get 8? What you're actually multiplying by is 1/2 or 0.5. If you take 20 times 0.5, you get 10. So multiplying by 1/2 gets you from 20 to 10. Multiplying by 1/2 gets you from 12 to 6. And we talked about going this way is times 2, or 2 over 1. Going this way, it's going to be the opposite, 1 over 2. So the two scale factors here, depending on which direction we're going, are 2 and 1/2. All right, now we're going to fill out this chart and start to see what happens to the area and the perimeter from this shape to this shape, because all the sides have doubled. So let's see what happens to the area and the perimeter. So the original triangle, the base was 8, right here. And in the original triangle, the height was 6. In the new triangle, the base is 16 and the height is 12, doubled. If I want to find the perimeter of a shape, I just add up all the sides. So if I add 10, 8, and 6, that's 24. Perimeter of the smaller or the original triangle is 24. How about this one? If I add 20 and 12, that's 32, plus 16, that's 48. So look at this. Times 2, times 2, times 2. So if I double the sides, look at the perimeter. What happens to the perimeter? It doubled. So it increased by the scale factor. And the reason that is because if you double the side, double the side, double the side, perimeter is just measuring the distance around. So if you double everything, it's now twice as far around. So the big misconception now is that area is going to follow the same suit. And I'll just tell you up front, it's not. Okay, the area is not going to double. So let's go ahead and find the area real quick. So of the first one, remember, it's 1/2 base times height. So we're going to go 1/2 times 8 times 6, using the base and the height right here. So half of 8 is 4, and 4 times 6 is 24. So the area of the first shape is 24. And if you had to guess what the area was for the next one, most people would say 48. But let's see. It's still 1/2 base times height because it's a triangle. So it's 1/2 12 times 16. Half of 12 is 6. 6 times 16, 96. Okay, that's not doubling. If I go ahead and divide these two, if I don't see the relationship right now, 96 divided by 24 is 4. This is 4 times the size. Okay, so what happens to the area? It's 4 times the size. And we touched on this yesterday. Okay, the reason this happens is because the area is always going to increase by the scale factor squared. Oops. Scale factor squared. So the scale factor was 2. 2 squared is 4. It's 4 times the size. So if all of the sides are doubled, the area is going to increase by 4 times. Not by 2 times, by 4 times. And that's always going to be true. Whatever the scale factor is, if you square it, that's what the area is going to increase by. So let's slide down here. Are these similar? Well, 2 became 10 and 2 became 10. Yes. Every square is going to be similar because they're always going to be increasing and decreasing by the same amount. So the answer here is yes. If you wanted to prove it, you're going to do 2 over 10 equals 2 over 10. Scale factor here going from 2 to 10 and 2 to 10, I'm multiplying by 5. So if I was going the other direction, remember you just flip it. So going this way is 5 over 1. So going this way is 1 over 5. If I multiply 10 by 1 over 5, I'm going to get 2. So the other scale factor is 1/5. All right, let's test this out. Let's see what happens. So the original base was 2. The original height was 2. The new square has 10 and 10. Perimeter here, don't say 4. 2, 4, there's a 2 here and a 2 here. 2, 4, 6, 8. Distance around this one is 8. Distance around this one, 10, 20, 30, 40. So we increased all the sides by multiplying them by 5. They're 5 times the size. And the perimeter is 5 times the size. So it increased by the scale factor again. So perimeter is going to increase by the scale factor. If you double all the sides, if you multiply all the sides by 5, same thing happens to the perimeter. So let's test our theory. For area, we said it's the scale factor squared. So if the scale factor is 5, 5 squared is 25. So our area should increase 25 times. That's a lot. Let's see if that actually happens. So area is base times height for a square. 2 times 2 in this case. So that's 4. And so if this is 4, and I'm telling you that the area is going to increase 25 times based on my theory that you take the scale factor, you square it, and that's how many times bigger it is. Well, 4 times 25 is 100. This should come out to 100 if this is correct. So let's go to the second shape, base times height. It's a square, 10 times 10. Well, look at that. The new area is 100. I have multiplied the original by 25. It is 25 times bigger in terms of the area. And again, that's the, I keep writing square, scale factor squared. So it's really important to understand this concept that when we double everything, it makes the area increase by even more than that. If we triple everything, multiply everything times 5, the area doesn't increase by the same amount. It's that amount squared. So the perimeter was 5 times the size, 25 times the size on the area though. That's significant. That's not even close to the same thing. If it was 5 times the size and this area was 4, the other one would be 20. It's not 20, it's 100. Okay, that's a huge difference. So the common misconception that the area is going to increase by the same scale factor as the sides and the perimeter, okay, we have to make sure that we understand that's not going to happen. All right, let's flip it over. I want you to try these two. Okay, pause the video for a second and then see if you can run through these and have everything come out. And then I will run through these real quick. So pause the video, try these, and then press play again. Okay, so hopefully you already tried these. Again, if not, pause it, try them, and see how you did. So first things first here, are these similar? Now these have been flipped, so we need to make sure the sides match up. We've got 3 and 9. Does that equal 4 and 12? Does that equal 5 and 15? All of these are going to reduce to 1/3. So yes, they are similar. To get from the left to the right, these are 3 times the size. 3 times 3 is 9, 5 times 3 is 15, 4 times 3 is 12. And so going the other direction, it's going to be the inverse. It's going to be 1/3. So the base and the height on the original were 4 and 3. On the new one, it's 12 and 9. If I find the perimeter here, add them all up. 5 and 4 is 9, plus 3 is 12. So if these have all increased by 3, I can predict that this is going to be 36. So if I add this up, 15 and 9 is 24, plus 12 is 36. Okay, all of these are times 3. That's predictable. So the area, whatever it is, 3 squared, should increase 9 times. So the original area right here, 1/2 base times height for a triangle. So it's 1/2 times 4 times 3. So 4 times 3 is 12, take half, it's 6. So according to this theory, this shouldn't be 3 times the amount, this should be times 9. So this should be 54. Let's see. 1/2 base times height. Base and height are 12 and 9, so 1/2 times 12 times 9. Half of 12 is 6 times 9. 54. So 3 times the size for the perimeter, 9 times the size, which is 3 squared for the area. Okay, and the last one now, we're going to be looking at a reduction here. So are they similar? 12 to 6, 16 to 8? Yes, that all comes out to 2/1. So they are similar. The scale factor from left to right is 1/2. 12's becoming 6, 16's becoming 8. If I was going the other direction, it's 2. So running through this, original rectangle's base is 16 and the height is 12. The new one, the base is 8 and the height is 6. So we are multiplying by 1/2. So the perimeter, the same thing should happen. So if I've got 12 plus 16 plus another 12 plus another 16. Okay, I have a perimeter of 56. So this next one should be half the size. Should be. Let's make sure. So I've got 6 and 8. So 6 plus 8 plus 6 plus 8 is 28. So sure enough, multiplied by 1/2, it's half the size. All right, so the area should be the scale factor, which is 1/2 going this direction squared. Well, think about what squared means. It means times itself. So 1/2 times 1/2 is 1/4. This should be the scale factor for the area, basically. So what I'm multiplying the area by, it should be 1/4 of the size. So first one, base times height for a rectangle, 12 times 16 is 192. So this should be 1/4 of the size. So area is base times height. It's 8 times 6, which is 48. And so how do I tell if this is 1/4 the size? Divide. 192 divided by 4 is 48. So this is 1/4 of the size. So what happens to the perimeter? It's half. What happens to the area? It's 1/4, which is 1/2 squared. So even in a reduction, it's still going to be the scale factor squared.